All right. Let's do, you have two more skills in this section. And one is to convert from radians to degrees and degrees to radians. And because we have this circle, and if we start here at 0 and we go halfway around, that's pi. And that's also 180 degrees. So if we're talking about radians or the length of a radius, that's 3.14 exact would be pi, but they're equal. And so if you take pi and I divide it by 180 degrees, that's equal to 1 whole. They're the same thing. So I can multiply anything by this ratio and it doesn't change the fraction. For example, if I had 1/2 and I times it by pi over 180, I would still have 1/2 because this is 1. All right, so keeping that in mind, we're going to change degrees to radians. And all you do is you take the degrees and you times it by either 180 over pi or pi over 180. And the way that you know which one is, if it's degrees, you want the degrees to cancel, so you put the degrees on the bottom and then the pi on top, because now the degrees will cancel with degrees, and then you'll have 80 pi over 180, but we don't want that. 80 pi over 180, that's not lowest terms. So you can either put that in your calculator and reduce, or actually I'm just going to divide them both by 10 and I'll get 8 pi over 18, and I'm still not in lowest terms. So I'm going to cut each of those in half and divide 8 by 2 and get 4 pi, and divide 18 by 2 and get 9. So 80 degrees is the same as 4 pi over 9, and I'm going to sketch that. So here's my 0, here's 90. So 80 degrees is about right up here. And 4 pi over 9, let's see. If I go all the way over, that's 9 pi over 9, because that's pi. So 9 pi over 9, so half of that would be 4.5 pi over. So 4 pi over 9 checks, because I would have 1, 2, 3, 4, 5, 6, 7, 8, 9 pi over 9. Okay, let's do 260 degrees. So I'm going to times that by pi over 180 degrees, so the degrees cancel. And then I just need to reduce the 260 pi over 180. I do the same thing. I take the zeros out, divide by 10, so that's 26 pi over 18, and then I can divide both of those by 2 again, 13 pi over 9. And we'll do the proof. And so again, we have 9 pi over 9, that's from 0 all the way. So 13 pi over 9 is going to be 10, 11, 12, somewhere down here. And 260 degrees is somewhere right here, because 270 is straight down. So that checks. Okay, now let's go backwards. Let's go from radians to degrees. So I'm going to take my 2 pi over 5, and instead of, I want the pi's to cancel, so I put my pi in the bottom and my 180 degrees in the top, and then I times these. So that means that I can cancel, and 5, so I would have 2 times 180 divided by 5. I'm going to cancel the 5 into the 180 and get 336. So that looks like 72 degrees, 2 times 36. And let's check it. So 2 pi over 5, I start with 5 pi over 5, because that's pi. And then 2, so it'd be 1, 2, 3, 4. So 2 pi over 5 would be about here, which looks like about 72 degrees. All right, and now some of them might get a little strange, and that's 2. What does that mean? That means 2 radians. 2 radians. Remember, a radian is about the size of the radius. So 2 radians is going to be somewhere around here. Okay, because there's 1 radian, 2 radians. Okay, but let's see how many degrees that really is. So we want it in degrees, so the degrees stays on top. That's how we want my answer. Now this is strange because the pi's aren't going to cancel, so I actually need to use my calculator on this one and do 2 times 180, which is 360, and divide it by pi. And if you could do that on your calculator, 360 divided by, and find the pi button, you'll get an exact answer. I get 114.6 degrees. So I'm going to say about 115 degrees. And if I look at my circle, this is 180 degrees. This is 90. So that could easily be 115 degrees. So that checks. Okay. Now, here's one more skill. We've done this before, only we did it in degrees. So I want to find an angle that's coterminal with these. That means it's the same angle, only it goes around the circle once or go one way or the other. And this time I want it between 0 and 2 pi radians. Okay, so what does that mean? That means this is 0, all the way around is 2 pi. So if I go 13 pi over 4, let's see, this is 4 pi over 4, and this would be 8 pi over 4. So if I start here, and I went, that's 8 pi over 4. I have to go 5 more, so here's 4 more. So it's going to be somewhere like right around here. Okay, but don't worry about the picture. Let's just subtract 2 pi. And I'm subtracting it because if I add it, it's going to get bigger, and I want to get it in between 0 and 2 pi. And if I'm working with force, 2 pi is 8 pi over 4. All right, so let's subtract 2 pi. And 2 pi is the same as 8 pi over 4. And I'm using that because we're in force. And that leaves me with 5 pi over 4, which is right here, 5 pi over 4. And that works because that's in between 0 and 8 pi over 4. Okay, now if we have a negative 3 pi over 4, that's going to be this way, negative 1 pi, 2 pi. Ooh, that looks like it might be the same angle. Let's try it. So we're going to add 2 pi. So that's going to be add 8 pi over 4, and that gives me, sure enough, that's the same angle. Okay, so finding coterminal angles, if we're in radians, you add or subtract 2 pi. Say if it was thirds, 7 pi over 3, then I would subtract 2 pi in thirds would be 6 pi over 3, and that would give me 1 pi over 3. So that means that 7 pi over 3 and pi over 3 are coterminal, same angle. Okay, and we have one more skill that you need, and that is to use the formula for finding the arc length of a circle. So here's the formula. S is going to be the length of the arc. R is the radius, and theta will be the angle in radians. And this is a nice little, see. So here's my radius, and let's say the angle goes up to here. So that's going to be my angle in radians. And then S, which is this is going to be the length of the circle. Okay, so let's see if we can solve a problem here. A person walks 140 degrees around a circle with radius 50 feet. How far do they walk? Well, let's draw a little picture. Let's say they start here and they're walking 140 degrees. The radius is 50 feet. Now this is 180, this is 90. So 140 is going to be about, I'm going to say right there. Okay, so they're walking right here. Oops, let's undo that. They're walking right here, and we want to know how far did they walk. Well, if this is 50 feet, we know it's more than 50 feet, okay? So the first thing to do in a problem like this is look at our formula. S equals R theta, but theta has to be in radians, and we have degrees. So first we're going to change 140 degrees into radians, and how do we do that? We times it by pi over 180 degrees, so the degrees cancel, and we get 140 pi over 180. We could reduce that, zeros out, 14 pi over 18, cut them in half, 7 pi over 9. And so we'll use that in our formula. Okay, so we're looking for S. We don't know how long that is. So S equals, the radius is 50 feet, and the angle is 7 pi over 9. Now at this point, I'm going to take my calculator, and I'm going to times 50 times 7 times pi, and then I'm going to divide it by 9. Okay, so 50 times 7 times pi equals 1099.56 about, and divide that by 9, and I get 122.2 feet for my answer. Now let's see if that makes sense. 50 feet is this long. So if I went 50, 50, so that looks like about 50, 50, it looks like about 122 feet. So that makes sense. Okay. All right. Let's try one more. There are two more actually, but let's do this. A wheel with radius 10. So here's the radius, 10 inches, rolls 25 inches. So it's going to roll 25 inches. So here's 10, 20, about that far. Okay, what angle has it rotate? So I'm looking for this angle in here, and that is theta. Okay, so let's use our formula. S equals R theta. We know that S is 25 inches. That's the length of the arc. So 25 equals, my radius is 10, and they're looking for the angle. So we'll divide both sides by 10, and 25 divided by 10, that's 2.5. So it's either 2.5 radians, or if they want to change that to degrees, you would put 180 degrees over pi. And again, I'm going to use my calculator. 2.5 times 180 divided by 3, or pi. I'll just use the pi button. And I get, let's see, 2.5 times 180 and divide that by pi, and I get 143.2 degrees. So either 2.5 radians or 143, looks like I went a little bit high here. Should be about right here, 143.2 degrees or 2.5 radians. And last but not least, find the length of the arc on the circle below. First thing you want to do, change 100 degrees to radians. Okay, so that's going to be, if I divide those, I get 10 over 18 or 5 pi over 9. And we'll use my formula. So S equals, radius is 12, angle is 5 pi over 9. Get my calculator out, and I'm doing 12 times 5 times pi, and I got 188.5 about, divide that by 9, and I've got about 20.9 is the length of that arc, or I'm going to say about 21, and it is centimeters. And let's see if it makes sense. If this far is 12, and that's 12, almost, yeah, that looks great. Okay, and that is the end of section 5.2.